Alright, so now we're going to finish section 6.1. This video is going to just simply analyze special systems of equations. Right, in order for us to analyze them, there's a few terminology that we need to know first. And the first one is we can have a system of equations that is either inconsistent or consistent. Alright, so we can have two options, inconsistent or consistent. And what is the difference between these? Well, a consistent system of equation has at least one solution, whereas an inconsistent system has no solution. So inconsistent has no solutions, and inconsistent has at least one solution. All right, now, once we know that a system is consistent, meaning that it has solutions, it could be one of two things. It could be dependent or it could be independent. And if it is independent, it has exactly one solution, whereas if it is dependent, it means it has infinitely many solutions. All right, so once we know it's consistent, it could be one of two things. It could be independent or dependent. And independent means it has exactly one solution, whereas dependent means it has infinitely many solutions. All right, so this is a possibility that we can have when we have a system of equations. Inconsistent means no solution. Consistent means exactly one solution, but then once you have consistent means at least one solution, but once you have consistent, it can then be independent or dependent, depending on if it's just one solution or infinitely many. Go ahead and solve a problem with this. So we're going to have two different equations. We'll have the red one, 2y minus x is equal to 2, and then we'll have the blue one again, y is equal to 1/2 x plus 1. All right, we're going to just go through another way that we can graph that we've learned, which is finding our x-intercepts and our y-intercepts. So if I want to solve for my x-intercept, I set y is equal to 0. Oops, sorry, let me write that a little bit differently. I set y is equal to 0. So that means 2 times 0 minus x is equal to 2. 0 minus x is equal to 2. Negative x is equal to 2. Divide each side by -1, so x is then equal to -2. So I know I had the point of -2, 0. So I can plot that point, -2, 0. Then for my y-intercept, I know I set x equal to 0. So that means 2y minus 0 is equal to 2. 2y is equal to 2. Divide each side by 2. Y is then equal to 1. So I have the point 0, 1. All right, so I know that is my second equation. So now I'm going to graph this red equation based on those 2 points. Remember, you guys will use a ruler, so your lines can come out nice and straight. Mine are a little off right here. It's a little hard for me to draw on this. All right, so that was using one of the other methods we did. So I just wanted to just review over that because that is something that we've learned in the past. Here we know it's already in y is equal to mx plus b form. So our slope is equal to 1/2. And our b is equal to 1. So then if we go ahead and we plot this point, so we plot it at 1, our y-intercept is 1, and then now our slope is up 1 over 2, up 1 over 2, down 1 over 2. So if you notice, all these blue points fell exactly right on top of our red line. So if we go to graph this, the two lines are actually one and the same. It's so much the same that this program can't even distinguish between the two. When I drew the blue line, it automatically went to the red line. So let me just keep drawing this until it stops going to the red line. All right. So that means that these two lines lie exactly on top of each other. Every single point I pick that satisfies the blue line will satisfy the red line. And every single point I pick that satisfies the red line will satisfy the blue. So this means that they are infinitely many solutions. So we would say that this graph, or that this system, is consistent because it has at least one, and it's dependent. All right, so it's a dependent system of equations. Now, we did this one by graphing, but let me erase all this here. One of the things that we went through in the last section, or last chapter, when we were talking about parallel lines, is if two equations, so if we had this 2y minus x is equal to 2, if we were to solve for y, so add over x, 2y is equal to x plus 2, divide each side by 2, y is then equal to 1/2 x plus 1. So when we put it into slope-intercept form, you saw that we had the same slope, which we know that that means that they could be parallel. But since they have the exact same y-intercept, that means that the two lines are exactly the same, or the word that we went over, that they coincide. So this means that they are exactly the same equation, the same line. And that lets us know that there will be infinitely many solutions, and that it will be a dependent system. All right, so that's going through solving by graphing, which if you didn't want to graph that one, if you put these both into this form here, y is equal to mx plus b, and identify, well, wait a minute, they're the same exact line, you can stop there and say, okay, this means that there are going to be infinitely many solutions because they coincide, so it means it's consistent and dependent. All right, so then for this one here, we're not going to graph it. We're just going to look and say, oh, well, it's already in slope-intercept form for us. This slope is equal to 2. This slope is equal to 2. They have different y-intercepts, so that means that they are parallel. So the definition of parallel lines is what? Parallel lines tells us that they never ever intersect. So that means when we graph these two graphs, they will never touch. So there's never a point in which they will satisfy both at the same time. So this means that there is no solution or inconsistent. Right? We would say that these two systems are inconsistent. So when you're solving for these special systems of equations, you can graph it if you'd like, or if you just identify while they're parallel or that they coincide, then you don't have to graph it and you're able to go ahead and solve for it right away immediately. All right? And this is the different types of systems of equations that we can have. We can have one solution where they intersect at exactly one point. We can have infinitely many where the two lines are exactly the same, so they will be stacked on top of each other, which means every point that satisfies one satisfies the other. Or they can be parallel, which then means that there is no solution. All right, so we can have infinitely many where they're the exact same line. We can have no solution where they are parallel from each other and they never ever touch or intersect. Or we can have exactly one solution, which is where the lines intersect at one point. This is all the different types of solutions that we have. There's no way that when we have two lines that are graphed that we can have either 2 or 3 points, or 2 or 3 solutions. It's either one solution, infinitely many solutions, or no solutions. All right, that's it for this video, and that's it for this first section.